So it's a 2.10 method of variation of parameters. Okay, this is another method to solve the non-homogeneous equation. Okay, but there are two differences. I mean, it's better than MUC in the respect that, number one, P is function of X, right? Q is function of X. In MUC, that has to be constant, right? The numbers. Otherwise, MUC cannot handle it, okay? But MVP can handle it, can handle function of X's to the coefficient, okay? That's the first difference. And second feature is R of X can be any function virtually. Okay, it can be any function in R of X. In MUC, it has to be very simple special functions, right? Their derivative has to be come back to its original form, right? Within a finite number of differentiation. But this one, there's no limitation on that, okay? And third feature is it uses, MVP uses Y1 and Y2, which is homogeneous solutions, okay? It directly uses, Y1 and Y2. Okay, that's the special feature of this. So it's the most general. It's a more general, method, more general than MUC. Okay, and those are the features of MVP, method of variation of parameters. Okay. You don't have to worry about memorizing all the formulas. It's just one simple principle, okay? So YP, I told you, MVP uses Y1 and Y2. Okay, how? Like this. YP is U of X times Y1 of X plus V of X times Y2 of X. Okay, this is method suggested by Lagrange. Ooh, one of the genius mathematician, right? Lagrange suggested this. Okay, and he believed that having this, probably I can solve the system, the nonlinear system. Non-homogeneous system. Okay, that's what he suggested. That's what he proposed, and he proved. Okay, the method like this. So YP prime is U prime Y1 plus U Y1 prime plus V prime Y2 plus V Y2 prime. I told you need a little bit of patience. Okay, then there's nothing difficult there, right? YP double prime, U double prime Y1 plus U prime Y1 prime plus U prime Y1 prime plus U Y1 double prime plus V double prime Y2 plus V prime Y2 prime plus V prime Y2 prime plus V Y2 double prime. So we have to put it in, right? We have to put it in, substitute, but don't worry, just one time, okay? You don't have to do it again. Put it into the ODE, which is YP double prime plus P YP prime plus Q YP, right? You plug it in. So I'm not gonna write it, okay? Of course, right? Okay? Plus P times YP prime is U prime Y1 plus U Y1 prime plus V prime Y2 plus V Y2 prime. Okay? And plus q times uy1 plus vy2. Okay, so I'm gonna collect u terms. Okay, where is u? So where is it? Here, right? U times y1 double prime, and we have u here, u times y1 prime, right? uy1. Okay, so y1 double prime plus p times y1 prime plus q times y1. Wow, what is it? What is it? Homogeneous solution. Okay? Just 0. That's genius. Okay? Plus v. You take v terms out, and that's automatically this, right? It has to be, otherwise we can't, solve it, right? This one is 0, 2. So you have, half of that, you just cancels, okay? All right. That's what Lagrange did. Okay? And the rest term, the rest terms are plus u double prime u prime y1 prime. 자, 조금만 참으세요. 이거 한 번만 하면 된다 그랬어. 예, 돌아가서 안 해도 돼요. 대신에 이거 한 번은 정확하게 이해를 해야 돼. y1 plus v prime y2 plus u prime y1 prime plus v prime y2 prime. Okay, simply just rewriting it. And we know that this is 0. So, okay. So what are you going to do with the rest? Okay? What are you going to do? We see a clue. I mean, natural feeling is we got to do something with this, right? These are all, differentiation stuff, right? It's all related. Wow. Yeah, we could find a pattern from there, right? Which is d over dx u prime y1 plus v prime y2. Okay? These 4 terms is that, right? And plus p times u prime y1 plus v prime y2 plus u prime y1 prime plus v prime y2 prime previous equation, we made an assumption that y1 u prime y1 plus v prime y2 is 0. We made this assumption, okay? And so the equation became like this. Okay? By having this assumption, we would end up having that equation. This is what? 2 equations, right? 2 equations, 2 unknowns, right? 2 equation, 2 unknowns. y1 and y2 is simply coefficient. Okay? y1 and y2 is already known, right? From the homogeneous equation. So it becomes 2 equations with 2 unknowns. Then it's solvable. Correct? Solvable for u prime and v prime. Then you can integrate to get u and v, right? Then you get yp and you get y. See that? All right? So let me rewrite it. Let me rewrite it like this. Same thing. I'm just rewriting it. I'm not going to add new stuff. It's the same thing. So let's write this way. 0, y1 prime, u prime plus y2 prime, v prime is R. I didn't do anything. I didn't do anything special or new. I'm just rewriting it. Okay? Then this is 2 equations, 2 unknowns. You can get it, right? How? The famous one. How can you get u prime and v prime out of that? By Cramer's rule. U prime is W1 over W, W2 over W. Okay, W is determinant of the coefficient. Okay? So Y1, Y2, Y1 prime, Y2 prime. Okay, this W is eventually what? It becomes Wronskian. Okay? We didn't do anything related to Wronskian, but it became Wronskian, right? It's just Cramer's rule. We didn't intend to have, Wronskian here, but it eventually became Wronskian. Wow, that's enormous, right? Coincident or no, it's nature, right? It's the law of nature. It's connected. Okay, the reason that we are, getting Cramer's rule is nothing but it's having linearly independent, coefficient. Okay, that was implied, actually. And W1 is W1 is for u prime, right? The first variable, that's 0R y2 prime. W2 is y1 prime 0R. Okay? If you calculate that, you'll get this. Then you integrate it. So 2.10, example 1. So y double prime plus y is secant x. All right, so lambda square plus 1 is 0. That is plus minus I. So YH is C1 cosine x plus C2 sine x. Okay, that's how you do it. And we are ready to YP, which is, so that's Y1 and that's Y2, right? So U times Y1, which is cosine x, and V times Y2, which is sine x. That's our YP. Okay? And so that is actually our assumption, right? That was our assumption, right? And U prime Y1 prime plus V prime Y2 prime is R, right? That was our two relationships. And you understand that, right? How you come up with that, right? Then you do that. So U prime Y1 is cosine x plus V prime sine x is 0. Okay? And U prime Y1 prime is minus sine x, right? Plus V prime Y2 prime is cosine x is R, so it's secant x. So if you solve it using the Cramer's rule, okay, you're ready now here, right? And you have to apply the Cramer's rule. I'm going to give you Cramer's rule too. Okay? So don't worry about memorizing it. Just understand it. Alright? 자, 크레머스 룰도 다 줄 테니까 뭐 외워야 되네 뭐 이렇게 걱정하지 마세요. 열심히만 하세요. 그냥 이해할 수 있도록. Okay, then let me so what is it? U is U is minus sorry. U is ln cosine x. Okay, phi is eventually that's x. Okay, so our y is yp is ln cosine x times cosine x plus x times sine x. Okay. So our final y will be c1 plus ln cosine x times cosine x plus c2 plus x sine x. Y double prime plus 4 times y is cosine 2x. I'm gonna do this. Very interesting topic. Right? 자, 이거 문제는 이렇게 주어졌는데 나는 이거를 MUC와 MVP로 동시에 풀게요. 그지? 그래서 어떤 차이가 있나 한번 봅시다. 재밌지? 재밌어. 이렇게 안 돼 있다고 책에는. Alright. So lambda square plus 4 is 0. So it's plus minus 2i. So y homogeneous is c1 cosine 2x plus c2 sine 2x. Okay? So let's do it in MUC. So the functional, the family will be cosine 2x, sine 2x, but it's already there, right? So it has to be x cosine 2x, x sine 2x. Okay? But then our yp will be ax cosine 2x plus b times x sine 2x. And yp prime yeah, I'm sorry. Yp prime equal a cosine 2x minus 2ax sine 2x plus b sine 2x plus 2bx cosine 2x. Okay? And since, you know, we can collect 2x, a plus 2bx plus sine 2x, b minus 2ax. Okay? We can collect these terms. And yp double prime is minus 2 times sine 2x times a plus 2bx plus 2b cosine 2x, right? Plus 2 times cosine 2x times b minus 2ax minus 2a sine 2x. Okay? And you plug it in and you compare let me move on to new page. 4b times cosine 2x minus 4a sine 2x, which is cosine 2x. Okay, so a becomes 0 and b becomes 1 over 4. So yp is 1 over 4x sine 2x. Okay? So IP was that. Then the same, thing, I'm gonna using MVP this time. Okay? So our YP is U times cosine 2x plus V times sine 2x. Okay? And I'm going to use the equation cosine 2x plus V prime sine 2x is 0. Okay, minus 2 U prime sine 2x plus 2 V prime cosine 2x, which is our R, which is, okay? And you do the Kramer's rule. And let's see. Your U prime will be minus 1/2 cosine 2x sine 2x. V prime is 1/2 cosine 2x to the square. Okay, so U will be, let me skip it, cosine 4x, and V is, where is it? 1 over 4x plus 1 over 16 sine 4x. So YP is 1 over 16 cosine 2x plus 1 over 4x times sine 2x. Okay, so your YP was 1 over 4x times sine 2x. You have another term there for the MVP.